All right. All right. Hello, good morning, everybody. We will be starting slightly, let's say, in the next 5 minutes. So just bear with us. We have to sort out a few logistical issues. Thank you for your patience. We'll be on in a minute. We have 47. see if I have members of the committee there. Okay, let me start. All right, welcome, welcome, welcome. I'm going to start by welcoming you and thanking you for coming to assist in this webinar series. It is in the context of Tuskegee University Interdisciplinary Seminar Series. This interdisciplinary seminar series oversees research by faculty who want to showcase what they are doing in terms of research and for students to familiarize, just as well as faculty also to familiarize themselves with their research. I would like, before I welcome our speaker, to thank members of the committee of the interdisciplinary seminar series. I have seen a number logged in, Dr. Abogri, Dr. Isunga. There should be a few more either coming in. So to start with, I would like to introduce our speaker for today, who is somebody I have the pleasure of calling a friend, a brother, and jokingly, my Royal Highness. That is Dr. Ntam, who is an assistant professor of physics here at Tuskegee University. He's been assistant professor here since 2012. And currently, besides his teaching responsibility, he serves as the faculty coordinator and mentor for the Office of Distance Education and Online Learning. He is also the E-Ambassador for the College of Arts and Sciences, and his responsibilities include, amongst many things, training and assisting faculty desiring to transition from traditional classroom instruction to online teaching. Dr. Ntam assists faculty in completing the training for teaching online. He also assists them with instructional design for new online courses. And as ODL, that is the Office of Distance Education and Online Learning Coordinator, Dr. Ntam seeks out and better test new technologies that provide support not only to students, but faculty with online learning and teaching. He does this through professional developments and workshops, and this is just one of them. So we all know that following the outbreak of COVID-19 pandemic, Dr. Ntam actually helped coordinate a series of fast-track training workshops to facilitate the transition of all instruction at TU to remote delivery. So for my students here present, if you are having your online instruction with ease, no, Dr. Ntam was responsible for it. Dr. Ntam also continues to provide one-on-one support to TU faculty during this transition. And it should be noted that Dr. Ntam, since 2016, has developed 4 open source textbooks for use at Tuskegee University. And he has done so for introductory algebra and calculus-based physics courses. The result of this open source textbook has been the saving students have realized, a total of about $150,000 in saving. That's an average of $200 per student in saving. So I hope at the end of this presentation, Dr. Ntam would have informed us on how to join the Libretexts community. He would also request faculty account on Libretexts platform and would actually outline steps of remixing existing open ed content in an open book, amongst others. So I would pause at that and request we welcome our speaker for the day, Dr. Ntam. Dr. Ntam, you are welcome.
Thank you, Professor Ndé, for that generous introduction. Good morning, good afternoon, good evening to everyone, depending on your time zone. Thank you for joining this online webinar. So today we'll be talking about an effective way to reduce student debt and promote active learning. And as Professor Ndé outlined, hopefully by the end of this webinar, many of you will become aware of the open educational resources available out there and how to take advantage of those very excellent learning materials in mitigating one of the existing problems or barriers for student success, which is the rising and continually rising cost of textbooks, especially in the context of this pandemic and economic crisis. So I'd like to begin with this short video on the state of textbooks and student debt. Let's listen.
When you consider the cost of education in today's society, you have to think big, really big. For example, $100 million is a lot of money, but if you had it in $100 bills, you could easily fit it all onto a standard pallet. And even if you increase that amount to $1 billion, you could still just run out, get 9 more pallets, and stack it all on that. But if you up the amount to $1 trillion, well, then you'd find yourself needing 10,000 pallets. That's right. In fact, if you stacked up $1 trillion in $100 bills, the stack would be 670 miles high. And that's why we all need to be concerned about student debt, because at more than $1.2 trillion, it's out of control. And we must act now. Fortunately, an effective way to cut student debt considerably is right within our reach. Open textbooks. It's estimated that students spend up to $1,200 annually on textbooks, and open textbooks can greatly reduce or even eliminate these expenses. Thanks to digital transmission, storage, replication, and delivery, many costs associated with traditional publishing simply don't exist with open textbooks. And saving money is just one of their many advantages. They're especially suitable for lower-level courses where content is similar among institutions. They can be readily updated to include the latest knowledge, and open textbooks become interactive experiences rather than static, engaging students and even enabling them to contribute to the text development. Open textbooks are being used more and more by a wide range of colleges, universities, and institutions. Their use is also being encouraged and supported by prominent philanthropic organizations, as well as by the federal and state governments. Of course, developing quality open textbooks is expensive, and faculty reaction to them is mixed. But as their use continues to grow, you can find out more about their impact, not just on education.
So that's the...
When you consider the cost...
That's the short introduction on the state of play as far as student debt and textbook costs are concerned. So the focus for today's presentation is the Libretexts platform. And the Libretexts platform is an open source textbook authoring platform that allows faculty and scholars in a cooperative effort with students to develop an easy to use online platform for construction, customization, dissemination of open educational resources to reduce the burdens of unreasonable textbook costs to our students and society. Now, on a personal note, when I was a student at the undergraduate level in Cameroon, that is West Africa, I could hardly afford any of the texts, that were prescribed for the class. The way I survived was I had to work doubly hard so that most of the students in my class who could afford the textbooks will bring their brand new books, to me to read and help them, understand the contents. That's how I survived, through that period. So when I became aware of this, this project to make textbooks, especially physics textbooks, which are, really expensive, accessible to students, talented students, that academically talented students, but students from disadvantaged financial backgrounds, it really struck a chord with me. So I consider myself, an ambassador to, the open textbook movement and the liberal, I share the Libretexts mission. You can read more about Libretexts, through this link, and the Libretexts, the various teams, the administrative and the technical teams. So the founder and director of Libretexts is Dr. Delmer Larson. He's a professor of chemistry in the University of California, Davis. So the Libretexts project consists of 12 independently operating and interconnected libraries that focus on augmenting post-secondary education in specific fields in both STEM fields, social sciences, humanities, business. It is supported by the National Science Foundation, and in 2018, the project received $5 million pilot grant from the Department of Education. So the project the Libretexts project is being built by over 1,000 active developers, including students, instructors, and outside experts across multiple campuses and nations. So briefly, these are some of the characteristics of the Libretexts platform. It is open. So that means all Libretexts libraries are accessible to everyone as long as they have access to the internet. And these libraries are completely free. Free in that it doesn't cost you a dime to buy any of the content that is made available through this platform. So Libretexts believes that everyone should have access to knowledge. The Libretexts platform is comprehensive. So it's a network that provides access to free open source textbooks and the library through which new texts can be developed and shared. So if you're an instructor teaching introductory level courses, you may discover that someone has already developed a book that matches your syllabus. So you can adopt this book directly and use it free of charge for your class. Or if you want to modify a few things, you're free to use the platform to remix existing textbooks and tailor the content to your class. The Libretexts platform is interactive, so it brings it provides the possibility to incorporate interactive visualizations, and this is a distinct advantage over the static nature of traditional textbooks. So students can engage more with visualizations. They can look at different models from different angles and become active participants in their learning as opposed to passive listeners. So research shows that interactivity promotes learning with greater understanding. The Libretexts platform is topical and current, so it's always up to date. The developers are working round the clock to ensure consistency and to make sure the newest information is available. So to update a traditional textbook requires a learning cycle, and through the editors and the publisher. But with the online platform, it's easy to apply updates across the board. So this allows instructors to fine-tune the project for their needs, to adjust the content of a lab or an online course to meet the exact needs of the students. Libretext is accessible, so the texts are always accessible online. And Libretext is undergoing major efforts to promote assistive technologies across the platform. So it's not only accessible online, but they're doing everything to make sure learners with disabilities have access to the content through assistive technologies. So Libretext is continuously growing through the efforts of a fantastic community of active collaborators. And you can become one today, you can become part of the community today if you desire. So here are just a few numbers that I picked up from the Libretext web information page, and I was told that some of these numbers are already, outdated. So the real figures are much higher than what you see on this slide. So to date, over 398 textbooks, text maps, and Libretexts have been developed. 154 courses using Libretext, and 223 million students served, and over 31 million served or saved in textbook cost. Now, what's the difference between a textbook and a course? So when you get into Libretext, you can remix existing textbooks into a text suited for a class. And then you can also publish this text as a course. That means you make it available online. Students can access the links to every content and video or simulation in the textbook. And you can import this directly into your LMS, your learning management system. So several institutions, the ones you see here, and again, this map is not the most current, but this shows the various institutions that have already made the switch to Libretext. And for my classes, beginning 2016, that is over the course of 4 years, this is an estimate of the savings, the potential cumulative savings per year. So the calculation is based on the average cost of a physics textbook, which is $200, multiplied by the number of students taught in my classes, my algebra and calculus-based physics courses from 2016 to 2020. And you can see 2018 and 2020, I obviously taught an overload. That's why you see more students and savings of $37,000 and $41,000. So this is like the breakdown of how the calculation was done based on the enrollment per course. And this is not counting like the students in the intro lab courses. This is just counting the students taking the lecture courses. So how to request an account in Libretexts. So you would go to the web page, libretexts.org. And as you can see across this menu, these are the different libraries. You have biology, business, chemistry, engineering, Espanol, geosciences, humanities, mathematics, medicine, and right here you have physics. So you would click on the library in which your course falls, and then when you click the first time, you get an error message, obviously because you don't have a login account for that library. So let's watch this brief, simulation. So when you click on login, you get the error message, your sign-in has failed. Please verify your username. So you click on request instructor account. So once you click on request instructor account, it will take you to a Google form where you'll be asked to provide, some information, your email address, your institution, the reason for which you're requesting the account. It's a really short form. It takes less than 2 minutes to complete. And once you submit the form, you then wait for the Libretexts administrator to verify your information, and then you receive an email with instructions on how to log in and with an initial password, which you can change after logging in. So what else can Libretexts do besides remixing, existing content? So you heard earlier on that you could add animations like this interactive 3D model of a protein. So this will engage students much more than just reading static text. Students can play with the animations and view the different animations from different angles. And you don't have to have any technical knowledge to construct these animations. You can use the ones that are already available in the platform. You can incorporate them very easily into your textbook. So this is a 3D animation. And the figure to the right is the simulation of a surface using a mathematic software known as CalPlot 3D. So students can play with all of these animations. They can get engaged and become, active participants in their learning, as opposed to just passive listeners. Another interactive component of Libretexts is Jupyter. So for those teaching computational-based courses, Libretexts provides this powerful tool through which instructors can embed code directly into pages of their textbook for students to try. And currently, this platform supports popular languages like Python, R, Octave, and Jupyter. And as you can see here, you can embed some lines of code, and students can run a test right in the page of the textbook online to see, the sample results. And Libretexts is working hard to for the possibility of hosting dedicated computational resources to cover the needs of more data-intensive courses. And there is yet another powerful feature called hypothesis. So hypothesis is an annotation overlay that allows for both public and class-based collaboration. So students can add comments on different sections of the textbook, and all these comments can be organized into a class. Let's say all the students taking my Physics 301 class, I'll create a group for that class, and all the comments from that class will be organized into one page or one forum where it could be a discussion type of activity, or it could just be students reporting, any challenging areas in the textbook, and you can have all this together in one place. And everyone can sign up for a free hypothesis account through this URL. Now, if you're one of those who like having something tangible to study off, like the traditional student who wants to touch, a textbook as opposed to, just reading the electronic version, there's an option to download and print a PDF version of the open source text. And Libretexts is working on expanding its print system so that authors or students can request a full Libretext to print, or to print through a non-profit partner. So the cost again will be nowhere compared to the cost of a traditional textbook. So a 300-page book could be printed for less than $20. So literally, you're just paying for the cost of printing. So the textbook is still essentially free. But if you don't want to incur any cost at all, you can use the free electronic versions. So this is a copy of a textbook for my current Physics 301 class that was remixed this summer. So as mentioned earlier, using LTI or common cartridge system, it's possible to import a Libretexts as a set of links. So once you create your text and publish it in the platform, you can import the course into Blackboard or Canvas or whatever learning management system you're using. And all the links to the different chapters will reside in your LMS. So students don't have to, go to a separate website, they can click right in the LMS and go to each section, in the syllabus. So the common cartridge system is compatible with common elements like Canvas, D2L, Moodle, and Blackboard. And this is a speedy method for setting up assigned or recommended readings without having to manually copy over the links. So for the last part of this presentation, I'm going to go to the Libretexts platform and walk us through very quickly on how to remix content. And this remixer works best on the Chrome browser. So if your browser doesn't display anything, it's advised that you switch to Chrome. So let me take us over to the Libretexts platform. Okay, so here is the Libretexts platform. So let me click on biology, just for curiosity. And I'll try to sign in. Even though I have a username and password, see, it shows that my sign-in has failed. Please verify username and password. That is because I'm registered under the physics library. So my login will not work for the other libraries. If I needed access to any of the libraries, if I needed to work in any of the libraries, then I'll request an account from that library. But from physics, I can access textbooks under any library, textbooks on engineering, chemistry, and so on, but my account resides in the physics library. So if I click on physics, I'm already logged in, okay? Because I was working on this before the start of this meeting. So right here, you can see my name, and in I have a sandbox. I can view my contributions. I can customize my preferences. And then here I have the remixer. This is the tool that we're going to use to mix different contents. And then you have the downloads tab that allows you to download content that has already been, remixed and edited and published. So now courses, if we click on courses here, these are the courses that have already been published. And you can see Tuskegee University as one of the published, courses. And under here, you'd see my algebra-based physics 1 text. And you can see, the contents. Okay, you can see the contents of the text. You can download the PDF, the full book, through this tab. Okay, you can access the different modules of the textbook. These are the different modules, module 1, 2, 3, 4, 5, 6, 7, and 8. So let's go to the remixer. So this is where the action takes place. So the, to remix, so a new remix, that means you're creating a new textbook from scratch using existing materials. There is another mode called edit remix mode, which means you already had something you're working on and you just want to edit. So there's several modes, and you can load a previous version on which you were working. So let's say, let's call this physics 100, open text. And on the left panel, if you click on the drop-down arrow, you can see the different libraries. So I'm obviously interested in physics, so I'll search for physics. And under physics, I have the courses and bookshelves. So books are the contents that have just been remixed, but not published as courses. So for an intro level course, I'll take college physics. And here I have college physics by OpenStax. This is a platform I've used before. So by expanding, I can see all the chapters and content. And right here, I can pick whatever I want into my physics 100 open text. So right here, I'm going to just delete all of these existing chapters. And so nature of science and physics, drag it over. If I expand here, I already have one chapter in my open textbook, you see, and there's, because I selected, I enable auto number, that means the platform will number the chapters and generate a table of content for the material. Next, let's say I want kinematics. So chapter 2, kinematics, one-dimensional kinematics. And then chapter 3, let's go with two-dimensional kinematics. Chapter 4, dynamics, force, and Newton's laws of motion. Okay, so let's say this is all I need for this text. You can see in less than a minute, I've extracted content that I need for my class. Now, I will still need, later on to read through the different chapters to make sure, the content is consistent with what I expect and there are no serious errors or typos in the content. But there's a 90-something% probability that all the textbooks that are published here have content that has already been reviewed to the point where you're unlikely to find any serious errors or inconsistencies. So once I'm satisfied with the selection, I'll click on Save to Server. So Save to Server is like initiating the publishing process. So obviously this will run a little bit slower because my CPU is under intensive use with all of the video feed and the browsers open. But normally it doesn't take a lot of time, to complete. to complete this step. So now, here, there are some terms that the first option, transclusion, means you're adopting the content from the textbooks, but the content is still linked to that textbook. That means if the content, if the textbook from which you adopted this book is updated, the updates will apply to your adopted textbook. The second option refers to the case where you want to unlink your copy from the source, and this is highly discouraged unless you're going to do substantial editing to modify the material substantially. So if you select the second option, then you'll be responsible for updating the textbook from the moment it's published. So I'll confirm save to server, and then the remixing process begins. So we have 38 pages. And the remixing is going on. So we're up to 60%, 70, 80, 90, and we're done. Okay, so the remix is complete and the new text is available here. So that will be in your sandbox. So as you can see, the new text has 1, 2, 3, 4 chapters. Nature of physics, kinematics, two-dimensional kinematics, and the dynamics, force, and Newton's laws of motion. So let's go to two-dimensional kinematics. And I'm going to go to vector addition. So under vector addition, so vector addition and subtraction. So I'm going to click on edit. Let's go back, cancel. Okay, so I want to edit this section. I'm just going to click here to enter a new line, and I'll go to elements and then go to reuse. So content reuse. And here I'm going to search for a PhET simulation. And so these are existing simulations developed by the PhET platform. So let's look for vector addition. Vector. Okay, so vectors. Okay, so I'm looking for a simulation, not static content from any other textbook. But as you can see here, you can see different courses that have the content of vector addition and subtraction. And you could just add the content if you discover that some content was missing. So show more results. So PhET simulations. Let's go back to Okay, so Ohm's law, balancing act, Hooke's law, Faraday's law, charges, pendulum, interference, resistance in the wire. You can see the extensive nature of the simulations. Okay, so let's just pick the simulation on Hooke's law. That's not what I intended, but for some reason it's difficult to locate the vector addition simulation. But I've just, for purpose of illustrating, I'm just going to add this here and click on save. So immediately at the end of this section, you see a simulation here on Hooke's law. So students can go in and, you know, apply a force to a spring, adjust, determine the spring constant, apply a certain force, and they can see the displacement. So they can study the behavior of the applied force to the displacement and see if, you know, it follows Hooke's law, which says, you know, the restoring force in the spring is directly proportional but opposite to the displacement in the spring. Students can play around with the concept of parallel springs or springs in series and verify if the results shown in the simulation match with what is expected. So this is just one example. So for every section in the textbook, you can find a simulation and add it directly to the page. And as students read the material, they will, you know, have the opportunity to play around with the simulations, to engage with the simulations, and in a more, you know, interactive and active way as compared to, or as opposed to, you know, passively reading a static textbook. And I mentioned hypothesis earlier on. So vectors, let's say vector subtraction, I could select this sentence. And if I hover the mouse over this, you would see this option to annotate or highlight. The student can highlight this and the highlighted text will be visible just to them. But if you click on annotate, the hypothesis panel opens up and I'm already signed into Physics 301 group. I can type in a comment here, a follow-up question or something, and post to the group. And if I go to my hypothesis account, so let's go to the Physics 301 group. You see the comment shows up here. So all the students in this class, all the students, their comments or follow-up questions will appear in this one group. So, and all the comments are linked to the section in the textbook. You can click from here and go directly to the textbook. So you can organize a class discussion on any section of the textbook through hypothesis. So with that, I'm going to pause, and if we have any questions, I'll be glad to take the questions for, you know, the remaining 10 minutes.
All right. All right. Thank you, Dr. Ntam, for this wonderful presentation. I think the audience might have some questions. I requested if they had questions, they should post it in the chat. I don't have it. I don't have any question. All right. I think there is one here. There are a few questions. Let me read.
Okay.
They're asking, would you have to create a different login for different libraries?
Well, generally, you will only need an account in the main library that covers your area. So if you're teaching in chemistry, it's recommended that you create an account in chemistry. But from your account in chemistry, you can access all the textbooks that are available in the Libretexts platform. You can access textbooks from engineering, math, physics, and then pull the content into the books you want to remix. So you don't need multiple accounts across the libraries.
All right, there is a next question. I'll leave you to answer. It is,
Okay.
with this program, are you able to get physical books as well as online?
Yes, so you're able to request a printed copy, and you will pay for the cost of printing and shipping. So that option is there. And like I mentioned earlier on, Libretexts is working on streamlining the process so that they'll have non-profit partners that can deliver very cheap printing, the cost of printing, because printing a book that has about 400 or 500 pages, may be a little bit costly if you're printing it, through the traditional printing system. So Libretext is working with non-profit organizations so that the process can be further streamlined. So those who prefer physical textbooks, they can put in a request and they'll receive a printed copy at a very affordable cost. Again, the only thing you'll be paying is the cost of the printing and the shipping. So there's absolutely no profit on the book.
All right, thank you. Let's continue. There are a number of questions coming up, and you have a big thank you from Dr. Isunga, who would just like to know
Welcome.
if you can post the link where one would request an account. Just post it on the chat for everybody. That will be great.
Okay. And I will do that.
While you're doing that, there is another question trying to find out, are the books for business, for certain business classes, as well as economics, real estate, or investing available?
Well, I cannot answer that question because I've not personally explored the business libraries, but whoever is interested, they can go to the Libretexts platform. Let me post the link here and explore for themselves. Again, they will need to probably, I'm sure they can explore the published courses, but they won't be able to log into the platform yet until they have an account. So let's see, business. Where is business? Right here. Okay, so if you go to the bookshelves, so you can see the 6 titles here: accounting, business, finance, management, law, marketing. So you can explore and see the different topics that are covered without even logging in. So let me just copy this and paste into the chat. Okay, there is social sciences, humanities, so explore and see what is available.
Okay, thank you. There is one other question. Wondering if Libretexts can support a fully virtual lab course at Tuskegee University, say for physics, chemistry, engineering, or biology.
So let's go to physics and let's go to the courses. And University of California, Davis, this is where the project resides. So this will be the one that has the most content. So as you can see here, there's some lab courses. So you will have to, there's biophysics. You have to explore this content to see if it matches your syllabus. If it doesn't, then you could extract the one that matches the content of your syllabus and then pull some other content, maybe from the Fed simulations, to build your virtual lab. So this, for instance, has applying thermal phenomena, models of thermodynamics, particle models to matter. So this may suit one person's lab, it may not suit everyone's lab. So you have to look around, kind of shop around and see which existing courses meet your needs. If you're lucky to have one that's identical to what you're doing, you could adopt it directly, or you have to put in some work and extract what meets your course and then pull the remaining or build the other content yourself.
All right.
Any other questions?
I'm waiting to see if there is anybody with another question.
And participants can unmute themselves,
yeah.
I believe, at this point, and also ask a question.
If you're a participant and you have any comment.
So Dr. Ntam, thanks again. I didn't know we could unmute ourselves. This is an excellent presentation. Thank you so much. I went to the link that you provided, yes. And I can't see where to request for an instructor account. I couldn't see how to do that.
Okay. Okay, so when you go to let me reshare the page.
Yes, sir, please. Thank you.
Okay, so I was showing this example where you have a physics lab with some contents that you can pull from. Now, when you go to this page, what is your library?
Business.
Business. So you go to business. You go to business, and then you kind of attempt to log in. Just click on login, and then you see the request instructor account appears. So when you click on request account, it takes you now to the form where you request the account. Does that answer your question?
Yes, sir, it does. Thank you.
Okay, you're welcome. Yes. Any other questions?
Any other question? If we would request participants, if you have any other any comments or questions or reflections, this is the time. Well, since questions are not coming, I understand everybody is well satisfied, and I will thank you immensely, Dr. Ntam, for this excellent presentation. Other participants have sent their thank you messages on the chat.
You're welcome.
So, we would consider your presentation coming to an end, and we'll thank the participants for all coming, and we hope to see you guys next time. You have a blessed and wonderful morning. Thank you all.
Thank you, everyone. Thank you for attending this presentation, and have a good rest of your weekend. I see a raised hand. Somebody raised their hand.
Somebody raise their hand?
Yeah, so
if there is a, then we can go ahead and take the question.
Yeah, but everyone is free to go. So the presentation has ended. But if anyone has a question, I'll be here for a few minutes to answer, any pending question.
Oh, John, Mr. John raised a hand.
Okay, can you unmute yourself and ask the question?
I'm trying to unmute him.
Yeah, it looks like they're using two lines, so a phone line and internet line. So they may be having some technical problems.
Just want to say I was able to go to the to get to the request instructor account, so I got it. Thank you so much. Thank you.
You're welcome. So there will be a follow-up workshop. I failed to mention this. There will be a follow-up workshop for faculty who are interested in going forward. We will have a session during which you can have hands-on, experience remixing your first open textbook from the available resources.
Yes, sir.
All right, Dr. Ntam, Dr. Wayne Barr is asking another question, which I'll allow you to answer him. Whether he said you must have probably covered whether this platform is entirely free.
That's right. It's entirely free, and it's free to the users. But actually, it's free because it's supported by NSF and several philanthropic foundations. So it's at no cost to the students or to the faculty.
All right, Mr. John Ntam, you have the floor. We're not hearing you.
You can type your question into the chat if the audio is not coming through.
All right, we seem to be having technical difficulties with Mr. John. I see he's on, but can you just type your question to the chat? That will facilitate a lot of.
Okay, so he just typed that it's more of a remark than a question. So it's not a question, it's just a remark. So,
all right, so he's made a remark. Did you hear the remark?
I did. It says he's glad to be part of this great, meeting. Okay.
All right.
So thank you everyone for participating, and our meeting has ended today. And thank you, Professor Bill, for moderating.
All right. Now you're welcome, and we will be happy to have you on another occasion in the near future. Thank you very much.
Most definitely.
You have a blessed and wonderful morning. Cheers.
You too.
Thank you. Bye-bye.
Bye-bye.